Hey guys, welcome to Infrastructure as a Service, or IaaS for short, within NetApp. My name is Matt Norton. I'm a senior cloud engineer with the Cloud and Compute Services team. Today we will take a look at NetApp IT's Infrastructure as a Service portal, which is built on ServiceNow on the front end and Ansible on the back end. What makes this portal special for us is that it represents our first true self-service approach to infrastructure automation. In the past, we had automation, but it was generally kicked off by admins. With this portal, it's totally self-service, and the hope is to open it up to the entire company. On this slide, we have a high-level look at our IaaS architecture. On the left-hand side, you'll see ServiceNow represented. So ServiceNow houses the web portal that users will log into to provision things within IaaS. So a virtual machine, a logical load balancer, a storage bucket, etc. ServiceNow also houses our CMDB, so every piece of infrastructure that gets provisioned is represented as the CI. ServiceNow will also keep a nice paper trail using incident tickets or R items or change control records so that there is a good audit trail. It's easy to go in and see as an admin or as a user who has provisioned what was successful, what was not successful. ServiceNow will make an API call to our Ansible Tower API, and Ansible Tower will then launch the appropriate workflow playbook to execute the automation. Ansible will in turn talk to a number of cloud providers or third-party infrastructure providers. In our case, currently, we support Amazon as our hyperscaler and maybe Azure a little bit later. On-prem in our private cloud, we're using VMware, so Ansible will talk to all of our virtual centers to provision VMs. In terms of the hardware we use, of course, for our compute layer, we're using NetApp HCI. We're also using NetApp AFF, all-flash FAS arrays for iSCSI and NFS storage. And then for our bucket or object storage, we're using NetApp Storage Grid. We store all of our Ansible code and some other code, PowerShell and Python also, inside Azure DevOps. So Ansible Tower will use Git to talk to our Azure DevOps repos to pull in the playbooks. So we'll update again in the Git repo and then sync with Tower to pull in the latest changes. And then we're also using Azure DevOps to set up CI/CD pipelines for our workflows. So for each workflow that's supported within the portal, we have a pipeline that's responsible for testing, running various combinations and permutations to make sure that all the scenarios that our users may encounter are tested. Anecdotally, this diagram looked a lot different not that long ago. In between ServiceNow and Ansible Tower, we had a CMP solution from a well-known company. But what we found with our CMP solution, and really with a lot of CMP solutions that are out there, is that one, they're very expensive. Two, they do a lot of things that we don't actually need. And three, the things they do need, we typically already do with tools that we already have and know quite well on-prem. So in our case, it was much easier to eliminate the CMP layer to make things more streamlined and easier to support. On the next slide, we have a look at what our portal UI actually looks like inside ServiceNow. In the blue box, we have the build column. So this is your provision, deprovision for VMs, storage, logical load balancers, and a special POC area for VMs we call sandbox. In the green box, we have manage or day two operations. So you've already provisioned something, some piece of infrastructure, and you need to do a day two type operation. For example, a start, stop, reboot of a VM or a resize of a volume to extend it, etc. And then finally, on the right in yellow, we have the order history. So this is where that ServiceNow paper trail comes in handy. Everything that's done inside the portal is represented in most cases as an R item. So it's very easy to see as an admin who's provisioned what may have failed, easy for us to go and investigate. It's also helpful for maybe larger teams of admins or app developers who would like to see that someone else on their team provisioned a VM against the same application CI. Next, let's take a look at how the automation is stitched together. First thing we need to do is set up our template or playbook inside Ansible Tower. So again, Tower is pulling in our playbooks from our Git repo that lives in Azure DevOps. So we set up a template and point it to the appropriate playbook. Next, we've got a look at the actual VM provision interface inside our ServiceNow UI portal. You can see that the user has to select an application that they have ownership for. They select a network accessibility, basically internal or DMZ, a landscape, the appropriate cloud region and availability zone, their operating system size, so on and so forth. Once they submit their request for whatever piece of infrastructure they're requesting, they will be presented with a screen like this, which represents an REQ or request item inside ServiceNow. Next, we have an example of what the API call between ServiceNow and Ansible Tower actually looks like. In this case, again, it's a VM provision. We're passing extra vars in JSON format to Ansible Tower to kick off the template that we've set up. This is what the running job looks like inside of Ansible Tower. And then finally, once the job is complete, we are returning data from Ansible Tower to ServiceNow as an artifact. So the artifact in this case contains whatever information we need it to contain. We have IP address, a message, net mask, service ID, and also you can't see it, but at the bottom there's a job status. So whether the actual provision was successful or not. If it's not successful, then the request in ServiceNow is failed. Next, let's take a look at Azure DevOps. As I mentioned before, we have our Git repository inside of Azure DevOps. It's just standard Git repo. We used to have our Git repo on-prem in GitLab, but we've moved it to Azure DevOps, so we have better integration for CI/CD. For every workflow that we support within IaaS, we build a pipeline to test that workflow. The pipelines can be kicked off in one of two ways. One, a weekly cron, so whether the code has changed in that past week, we want to run it regardless. We want to run the pipeline regardless to make sure everything is still functional. Two, when a developer updates the code, so for example, updates an Ansible playbook and pushes that up to the Git repo, the pipeline will be kicked off and run to make sure that the code changes have not broken anything. If the pipeline is run and fails, then we know to go in and look, see what happened, and revert the code if necessary. This is just a sample of a given pipeline. You can see that we're specifying our triggers, which branch, the relevant files or playbooks that should cause the pipeline to be kicked off are specified here, as well as the cron schedule. Thanks for tagging along on this speed tour of NetApp IT's infrastructure as a service portal. In review, we looked at the ServiceNow front end. We selected ServiceNow because it's an existing, flexible, and well-known tool by admins and developers alike. On the back end, we're primarily using Ansible. Ansible is supported by most cloud and infrastructure providers out there, including NetApp, so it makes a smart choice. But finally, our approach may be different than your approach. So choose the right tools, software, programming language that works for you. Thank you. If you're interested in learning more about NetApp IT's cloud journey, please check out the related sessions on your screen. In addition, if you have questions for me or other presenters within NetApp IT, please join us virtually on November 5th. Thank you.